Hello everybody, today I want to give you something to think about. How do different tools work, tools that look similar? What's different about them? So what I have here is a Bosch drill and a Dremel. They're really quite simple in terms of construction. You've got a power source, which is a battery source. That then goes through some kind of power controller. In this case there it's the button. In the case of the Dremel it's a variable speed doohickey. There's a gearing mechanism of some sort, and then you've got the chuck at each end, the business end. The only real difference between these two here in terms of what components they have is there a clutch mechanism here. I'm going to ignore that, treat it like the clutch doesn't exist. Now, despite the similarities in construction, they work completely different, and you probably know that. You use the Dremel for grinding and cutting little things, maybe engraving, although this isn't very good for engraving because battery and you can't really hold it properly because the battery's counterbalancing it. And this is for drilling into wood and concrete and whatever else. But what makes them different? Now, I'm sure you've heard the term let your tool do the work. You just accept that. But what does it mean? Why is it different? Well, I want to have a quick little explainer about why it's important to think about the underlying, I suppose, physics. Right? I'm not a physicist, I'm not a scientist, but I understand this, I've read up on it. So, think about power. Right? How much power comes out at the business end? That's the amount of power delivered to the workpiece, as opposed to the amount of power that comes from the motors. Right? Because the power is affected by going through gearings and all that sort of stuff. Power is a function of torque and revs per minute. Now, torque is basically the rotational version of linear force, basically how well the motor can turn something given a certain amount of resistance. So basically how hard it turns against the material it's drilling into. You measure power in kilowatts. There are other ways of measuring it, but I'll use kilowatts for this. And to get so what you need to do is get the torque rating of the device and the RPMs, multiply the two together, divide it by 9.5488, and you end up with the power in kilowatts. One of the biggest issues is that manufacturers don't really like to give out torque ratings on their devices for some reason, and it could be a commercial thing. It could also be because it's really hard to measure. For example, if you take like an impact driver like this here, which is, there's a percussive action as it drills in. You can kind of hear it. That would affect how you measure torque, because the way you measure torque is you literally put an attachment in here and that goes into a device, and you turn it and that device then adds resistance, and there's a measuring mechanism in it. Very fancy, high-end measuring gear that costs a fortune. But anyway, manufacturers don't really like to give out torque ratings for a lot of their tools, which is a pity. They do have a torque rating for this. Which, to confuse matters, there's a hard and a soft torque rating, which I really don't understand. And if you go and search on the internet, you'll find that a lot of people have asked the same question, and the answers are a bit vague. There's something about drilling into soft materials and drilling into hard materials, and talking about how torque rating is affected by screwing stuff in. Either way, on the screen is a screenshot of an answer given on the official Bosch forums, which doesn't really answer the question, but there you go. So I'm going to use the soft torque rating, which is 29 Newton meters. Couldn't get a torque rating for this off the official Dremel site, which is odd because Dremel is owned by Bosch, so you'd think they'd have the same sort of details. So after a bit of searching around, I actually found a Chinese equivalent to this, where they actually did issue a torque rating. I don't know if it's the same, but it seems about right, and that's 0.3304 Newton meters. So if we multiply 0.3304 by 5,000 revs, which is the lowest this spins at, you end up with, and then you divide the answer by 9.5488, you end up with 0.17 kilowatts, very low. With this 29 times 500 revs, which is what this spins at, divided by 9.5488, you end up with 1.519 kilowatts. So on the face of it, it seems that this is a lot less powerful than that, and that's true. However, if you rev this up to full speed, which is 35,000 revs per minute as my door closes and creaks, and do the same calculation, you actually end up with 1.21 kilowatts, which isn't far away from this. Now, of course, the big difference is torque is how hard the motor pushes against resistance. So if I turn the clutch up to maximum, so I'm acting like the clutch isn't there, and I try and stop this, I can't. I could probably put it in the vice and stop it, but I'd probably break the motor. But I can't stop it, just can't. Now, oops, sorry, banged this tripod there. If I try the same with a Dremel, I can actually stop it. It just won't move at all. So I can stop that with my hand. It's probably not the safest thing to do. It generates heat while I stop it. But crucially, the motor detects, the mechanism, the electronics inside the device detects that I am stopping it. And oh, have I broken it? No, I haven't. So yeah, it detects whenever I try to stop it, and it shuts off. You can see the light flashing there for a second. So how can they have the same power output despite the fact that the motors are clearly different and the torque's different? Well, it's simply a different way of working. This uses torque to cut through wood. It just uses sheer power. This, on the other hand, it uses speed to its advantage. So even though it has very little torque, so for this, every time the blade or the sanding disc or the grinding disc rotates, it takes off a tiny amount from the material you're cutting, and it's microscopically small, but by doing it a sheer huge number of times per minute, in terms of like this, anything from 5,000 to 3,500 revs per minute, you actually cut off or grind off a decent amount of material. So how power is delivered to the workpiece differs between different tools, and that's why it's important to understand the underlying meaning of the phrase "let your tool do the work," because some tools like this use force to do their work. Some tools like this use speed. This is important because in essence tools exist on a spectrum where at one end the tool does its work using a combination of speed and low torque, and at the other end it's the reverse is true. The speed is low but the torque is very high. So let's take for example the Dremel. That exists at the low torque high speed end of the equation spectrum, sorry. This drill here is probably somewhere around the middle. It uses a combination of speed and torque to do its job. Looking at the other end of the spectrum, you've got these extreme hole cutting drills. This is the Hilti DD500, which has 129 Newton meters of torque, but it only revs at 200 to 300 RPM. So that is clearly using force to get the job done, torque. As for other tools, let's take a jigsaw. Even though the blade goes up and down, it rotates, and that sits probably closer to the Dremel, where it uses a combination of speed and low torque, because I'm sure you've seen at times where the blade jams. Circular saws, again, probably near the middle. Angle grinders, you're probably getting more towards the torquey end of the scale, because although they use speed to do their job, they still have fairly powerful motors in them. And routers, they would also be closer to the Dremel end, where they just simply use sheer speed. Like most routers are like in 30 to 35,000 RPMs. Of course the motor is a bit more torquey, but yeah, it's still, they rely on speed to do the job properly. So there you go. So that's what this video is about. It's just to give you something to think about. When they say let your tool do your work, that's what they mean. It's some tools you can't force them because they have no torque. You can't push them, whereas other tools you have to push them to make them work, and that's like the big high-end hole saws and angle grinders. So there you go, something to think about. Cheerio.